Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Hey everyone, welcome to this explainer. Today, we're doing something really cool. Our goal is clear and highly focused. We are literally breaking down the philosophy of software quality engineering into its absolute core principles. You know, we constantly hear buzzwords like software, engineering, and quality tossed around in planning meetings all the time, right? But what do they actually mean when you strip them down to their core? Well, that is exactly what we're going to map out today. So think about the complex apps or systems you interact with, or maybe even design every single day. What does it actually take to build truly flawless software? Is it, I don't know, just putting the smartest developers in a room and having them crank out code as fast as humanly possible? Or is there a deeper, much more rigorous philosophy at play here? Consider this explainer a journey. Together, we are going to discover the ultimate equation for software success by defining our raw materials, figuring out the methodology, and then ultimately combining them into one master discipline. Okay, let's dive right into this. Section 1, the foundational elements of software and engineering. To really wrap our heads around quality engineering, we've got to look at our very first set of conceptual building blocks. Now, obviously, we all know what software is, but its formal definition actually holds a nuance we usually completely overlook. Software is defined as a collection of computer programs, procedures, and possibly associated documentation and data pertaining to the operation of a computer system. The really crucial point to take away here is that software isn't just the raw code. It's not just a bunch of Python scripts or lines of C++. It absolutely, crucially includes the documentation that explains how it works and the data that fuels the whole thing. It's the entire operational package you need to make a computer actually do its job. So, if we agree that software is this whole ecosystem of code, procedures, data, and docs, well, that naturally brings us to a pretty obvious transitional question. How do we actually build it? Like, how do we take those abstract raw materials and forge them into something that's functional, scalable, and, real? And that brings us to our second foundational block, engineering. By definition, engineering is the application of scientific and mathematical principles to design and build structures, machines, systems, and processes. Notice that word, application. Engineering isn't just guesswork, and it's definitely not winging it. It's the incredibly strict application of science and math. It represents a methodical, highly disciplined process of both design and construction. All right, moving on to Section 2, the true meaning of quality and what it actually means to meet specifications. Now, people throw the word quality around constantly in the tech industry, but usually they just mean this. Simplistically, a product meets its specification. Basically, if the blueprint says the software needs to process 10 transactions a second and it actually does it, boom, it's deemed high quality. But honestly, we really need to use this as just a baseline. It's literally the bare minimum required to say a job is technically finished, and it sets up a clear contrast for a much, much more robust standard that we really should be aiming for. Now, what's really interesting about this definition is how the ISO, the International Organization for Standardization, officially elevates this whole concept. They define quality as the degree to which a system meets specified requirements and customer expectations. Do you see the massive paradigm shift there? It's no longer just about checking off technical boxes on a spec sheet. Think about it. If you build a product exactly to the specifications, but the customer's expectations are totally missed and they find the thing completely unusable, well, that is not a quality product. True quality lives right there at the intersection of strict technical requirements and real human expectations. Let's move to Section 3 and see how this builds, merging the disciplines, combining software and quality. So we've got our individual building blocks, software, engineering, and quality. But the magic really happens when we start snapping these blocks together. Notice the distinct functions in this comparison. In the first column, we have software engineering. This is all about applying a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. It's super focused on the actual creation process. But over in the second column, we have quality engineering. This discipline takes those engineering principles and combines them with statistical methods and QA techniques to ensure the product meets quality requirements throughout its entire life cycle. So while software engineering is heavily focused on the development pipeline, quality engineering is statistical, it's rigorous, and it spans the entire lifespan of the product, literally from day one all the way to the day it's officially retired. And what happens when we mix software and quality? We arrive at software quality, which is defined as the degree to which a software product meets specified requirements and satisfies stated and implied needs. Now, I really want to draw your attention specifically to that very last part, implied needs. This is huge. True software quality obviously has to satisfy what the client explicitly wrote down in the contract, the stated needs. But crucially, it also has to satisfy the implied needs. These are the things the user didn't even think to write down, things like ironclad data security, lightning-fast load times, or just having an intuitive interface. Meeting those implied needs, that's exactly what separates good software from truly great software.
And that brings us to our grand culmination. Section 4, Software Quality Engineering Explained, the ultimate discipline.
This is the final stage where all those foundational blocks we just defined come together into one unified philosophy. Software quality engineering, at its absolute core, focuses on a few strict mandates. First, ensuring software meets requirements. That's our non-negotiable baseline, right? But then it pushes so much further, ensuring the software is reliable, efficient, and maintainable. Listen, it's not enough that the system just boots up on launch day. It has to be highly reliable over years, incredibly efficient in how it processes data, and completely maintainable so that some future team can actually update it without the whole architecture collapsing like a house of cards. Those specific attributes, reliability, efficiency, maintainability, those are the true hallmarks of a properly engineered system.
So, the crucial point here is this massive paradigm shift. Just look at the dynamic between these two ideas. On one side, we have detecting defects, which basically means you're finding bugs after they've already been coded and injected into the system. That is an entirely reactive approach. But on the other side, we have preventing defects instead. It's a complete shift from reactively hunting for bugs to proactively designing systems, implementing statistical methods, and building architectures that literally stop bugs from ever existing in the first place. You know, it's like fireproofing the entire building instead of just running around the hallways with a fire extinguisher. In simple terms, this entire complex discipline basically boils down to this one singular dichotomy. Side 1, building software correctly. Side 2, building the correct software. And this brilliantly illustrates the whole unified philosophy we've been building toward today. You absolutely need the and, uniting them both. Building software correctly means your code is squeaky clean, your engineering is mathematically sound, and your system is rock solid. But building the correct software, that means you actually solved the right problem. It means you met the customer's expectations and you nailed all of those tricky implied needs. Software quality engineering is the perfect marriage of doing the technical work flawlessly and making sure you are building a solution that truly matters.
As we wrap up this explainer, I want to leave you with a final thought to really chew on. Are you just finding bugs, or are you engineering true quality? Because if you want to build truly flawless systems, it takes way more than just writing code and reacting to errors. It takes a disciplined, statistical, and intensely proactive approach to ensure that every single stated and implied need is fully met. Try taking this unified mindset and applying it to the systems you build, and just watch how it transforms your results. Thanks so much for joining me for this explainer, and keep engineering for true quality.